be talking about the lava lamp first. So every once in a while, perhaps we can zoom in because I'll be using this too.
Ready to go.
Density, polarity. Density, polarity. Mesmerizing, isn't it? Katura Main here, coming for you live from the Headwater Science Center to look at lava lamps. Density, polarity. Very mesmerizing. Density and polarity, two of the very big reasons why lava lamps work. But now I have an opportunity for you to win a prize. I've been saying the word mesmerize a few times. Where does the word mesmerize come from? Give me a little brief history. Type it in on whatever you're watching us on, and let me know what the word mesmerize, where does that come from? And you could win a key ingredient to the lava lamps that I'm going to show you how to make. The ones we are making are not near as mesmerizing as this beauty, but you can win a prize if you answer the question. All right, on to it. Oh, wait. I have another way that you could win another prize. I want you to keep track of the amount of times I say molecule. Molecule. Got it? Right. Okay. Density, polarity, that's what I talked about in how all this works. So density. Density is the measurement of how compact things are, how close those molecules are pushed together. Oil and water, I should say oil and water, are two of the liquids we're going to be using for our lava lamps today. They have different densities. Water is a more dense liquid. The molecules are closer together. And I have the same amount of oil and water in these containers, and we are going to measure them. So let's turn on our scale. So if water is denser than oil, which one do you think will weigh more? Let's find out. Here's the water. This is being measured in grams, and we have 661 grams for the water. Now let's try the oil. And the oil is 642 grams. So the same amount of oil weighs less than the same amount of water. So density is very important to the workings of a lava lamp. Also, temperature makes a difference for density. As a liquid warms up, the molecules get farther apart. It gets less dense, rises up, cools off, and drops back down, and the cycle continues. So don't worry, you have 5 minutes to answer the questions. What is the background of the word mesmerize? So you have 5 minutes after the show to answer that, so you can win your prize of Alka-Seltzer. Okay, on to polarity. Polarity is the reason why these two liquids do not mix. Water is a polar molecule. It has a positive and a negative charge. Here we have a model of a water molecule. This big baby here is the oxygen atom. These two here are the hydrogen atoms, H2O, water, H2O. No. The hydrogen atoms give it a positive charge. The oxygen is a negative charge, and that makes a polar molecule. And you know what happens with a magnet. Here's another cute little molecules, water molecules. Opposites attract, and that happens with a water molecule. So water molecules are attracted to each other. Oil, on the other hand, is not a polar molecule, or is not a polar liquid. It doesn't have a positive or a negative charge. And that is why water and oil don't mix. The oil is not attracted to the water, so they don't mix. Oil would be on the top because it is lighter. Density, polarity, very important in our awesome lava lamp. All right, now it's time to make our homemade lava lamps. So we have some water in here. I mean oil, this is the oil. We're going to put a little bit more oil in here. And we're going to add a little bit of water. And where did the water go? The water went down to the bottom because it is more dense. I have a little bit of food coloring. Where do you think the food coloring is going to go? Food color is mostly water. So down it goes into the bottom. Then we add our key ingredient, which you could win by answering those questions. And I probably put too much in here. We'll see what happens. That sinks down, reacts with the water, and we start getting some bubbles. Needs just a little bit more water in there. Oh, here we go. We're starting to get some action with our bubbles. Now, those bubbles are carbon dioxide gas. The carbon dioxide gas is created through the Alka-Seltzer hitting the water, and then the carbon dioxide gas is lighter. It also kind of grabs hold of some of those water molecules. It gets lighter. It comes back to the top. The bubbles burst, and then the water that is denser than the oil goes to the bottom, and the process starts all over again. Mesmerizing. So this lava lamp also uses the same types of things that we just made our lava lamp with. We have a polar and a non-polar liquid, so they do not mix. And the densities of the two liquids are different, just not quite as different as the oil and the water. With this lava lamp, it does use heat. So there is a little bulb in here. It is heating up what's in the bottom, which is the more dense liquid. As that heats up, the molecules get farther apart, and it goes up to the top until it cools off, becomes denser, the molecules get closer together, and they go back down to the bottom, and the cycle starts over and over again. So, let me know, what does mesmerize come from, with a little explanation? And did you keep track of how many times I said molecule? Well, here's the deal. I didn't either. Everyone's a winner! Hooray! Hello.
Very nice. I'm just gonna get some close-ups.
All right, that sounds good. Yeah, I didn't put quite enough water in there, but it seems like it's working. Would you like to win the key ingredient to make your own lava lamp at home? And you can come check this out too if you like. Is that all right?
Yeah. No, we're still live. You can come up and check it out.
Yeah.
You want to show up on the stream briefly there?
So this is the stuff that's making the bubbles in that jar over there. So you fill jar mostly with water, mostly with oil, a little bit of water, a little bit of food coloring, and then you break one of those and put that in, and you can make your own lava lamp.
This thing is says it's got 33 minutes of recording left.
Yeah, I haven't ripped anything off of it in a long time.
I don't know how to take anything off, so everything I've ever done is still.
You have to delete it on the camera. You can't delete
groovy.
I didn't add quite enough water to that one. It should have a little layer of water in the bottom.
So does adding more water make it?
Adding more water would make it, and adding more water means the oil spills out. So I
So it
decided
would
not to do that.
Be a little more dynamic with more water in it?
It
Is
would.
that the idea?
Yeah. And you know, it's a side center, we can make a mess. I'll
Yeah.
get more water.
No, you got water. You need oil, don't
We need
you?
a bigger, we need
Bigger
a bigger
beaker.
beaker.
Oh.
Oh, yeah. Bigger beaker would help.
Beaker, beaker. Beaker, beaker, right?
Artsy Instagram post.
This way, I'll make more of a mess. It'll not be such. Well, let's just try it. I'm just gonna overflow the oil. We'll see what happens.
So the food coloring sticks to the water, right? Is that
So yes, the food coloring is water-based, so it sinks as well as the, just like the water does. And then, I don't usually put a whole piece of Alka-Seltzer in there. And then the Alka-Seltzer reacts with the water. And the water, and it creates carbon dioxide bubbles. So then the water also adheres to some of the carbon dioxide bubbles. So the combination of water and carbon dioxide bubbles is lighter than the oil, less dense. So it comes to the surface, and you can see there's little bubbles that are popping up here. So those are carbon dioxide bubbles that are popping. And then that releases that gas, which is the light part of our bubbles that are coming up. So then the water sinks back down to the bottom. Let's put another one in there. It really is kind of fun to watch.
have you fiddled around with different types of oils to see?
No, I really didn't do that. I know that you could use mineral oil or any kind of oil would work. But this was just some oil that has been sitting around the Science Center for just these kind of things. And nobody would ever want to use this oil for cooking, but it is just a vegetable oil. And there is a lot of different polar liquids. But then a lot of times what lava lamps use is a type of wax that warms up enough. So it's actually, when it's cold, it's actually more of a solid in the bottom. But lava lamps have changed over the course of the years. The combinations of the liquids has changed a little bit. The original ones aren't available anymore because they were dangerous and hazardous, just like so many of the wonderful toys we had when we were younger that they've taken off the market because they were dangerous. So, don't forget, you gotta tell me what mesmerized the background of that, and how many times I said molecule. Any answers? Oh, and by the way, you have to come to the Science Center in order to pick up your prize. These will not be delivered.
Getting them on the hook for these. Yeah, I did put it in the Facebook chat too. I posted the question to them in there just in case anyone missed it at the beginning. So,
Well, and perhaps we could give them a little bit of time on the mesmerized question.
Yeah.
You know, it doesn't necessarily have to be today.
Whoever gets it first.
And I know that some places they're saying, don't look it up. Look it up.
Yeah, look it up.
Look it up.
I look
Go right
stuff up
ahead.
all the time.
Yeah. It's really kind of interesting.
I've worked in places that are like, oh no, you can't have your phone out on the exhibit floor with you. It's like, why? I get to look stuff up all the time, right? Why wouldn't you want the collective sum of human knowledge in your pocket all the time before asking you questions all the
know.
time?
Right in your pocket. Just about anything you'd ever want to know.
I will say, one hint I gave you in if you're not trying to look it up, one hint I gave you when I put the question in the chat is I capitalized the word mesmerize.
Oh, look at you.
I don't know the whole story, but I know part of it. I know that is relevant.
There are so much great little history stories, little science stories like that.
Well, we can call that a wrap there. So, thank you all for watching. One thing I guess of note that was a little different about this stream that some of you may have noticed is that our Facebook stream and our Twitch stream were the same one today. So we got that rigged up, so no more shaky cell phone camera for Facebook. Also, we are live on YouTube also for these streams as well. So we're simultaneously streaming to all 3 platforms right now. It's kind of cool, I think. So you can pick whichever platform you like. We'll try and monitor the chats of all of them. And thank you for watching, and hopefully we'll see you in one of these days. And hopefully you guys learn about the word